This is Man Free World. I'm Chris Lapadopoulos at Anastasiopoulos. That portal is still open and needs to be closed at some point. And if anybody knows how to do that, today we're going to be talking about Sabine Hofstadter. Um, her video, "New Computer Will Mimic the Human Brain," and I'm kind of scared. And the topic I think is, will general AI ever achieve human consciousness? So let's get into it. Fair use, by the way. Go over, give her a like, and subscribe. She does good work for the most part, even though she's very math focused.
Australia is building a new supercomputer that'll for the first time both physically resemble a human brain and perform as many operations. About 200
Okay, so physically resemble. Okay, the model physically resembles the what people currently know, what scientists that study this have currently, the model, the abstracted layers of abstraction that they think describes how the neural network and the brain works, but they don't really know. There's all kinds of chemicals going on there. There's all kinds of external influences and like all kinds of strange quantum level interactions that are not currently in the model. So we have this abstraction of an abstraction of an abstraction.
128 trillion per second. The scary bit is how few operations these are. Yes, how few. Let me explain. The new supercomputer will be built at Western Sydney University. It's part of a new paradigm called neuromorphic computing.
Oh, Jesus, not a paradigm. Watch, she's gonna get into it a little bit. It's all still transistors. It's not a new paradigm. A new paradigm would be like using a xenon gas inside of a sphere that's pulsed with microwaves. That would be a new paradigm. But this is not a new paradigm. Stop.
Computing. That's computers modeled after the so far best processing apparatuses that nature has given us. Brains. Neuromorphic computing isn't the same as artificial intelligence.
Okay, first of all, I'm going to get into this a little bit later, but this whole thing about brains being it, no, our entire body and our social structure and the entire ecosystem is what makes us even possible. Stop, lady. It's not just the brain. This is the autisticness, this Cartesian mind-body split thing that I'll get into a little later.
Intelligence. These are two different research areas with different goals. What they have in common are neural networks. You may know neural networks as the most important software behind artificial intelligence.
Okay, neural networks are not big, scary, strange things. They've been around forever, since at least the late 80s. When I started messing with them. All it is a series of inputs, which is numbers, right? That go through a series of factors like multipliers, coefficients, basically, and then has another output that gets put into another layer of coefficients that go into another output. They go into there's a series of these things, and all they do is randomize the coefficients so that whatever the input is, the output is correct, and they keep running this thing until they get the right settings, and that's your neural network.
But while these neural networks do in some sense resemble the neural networks in the human brain, they're different from the real thing in one very important way.
Yeah, oh, I mean, lots of ways, lady. Let's be real honest. What they're modeling is the most basic, fundamental, like fuzzy view of what's going on. Sort of like looking at a fuzzy view of a city. You're seeing cars go in and cars go out and stuff go around, but you don't really know what the hell's going on. And at the people, it's like people inside there. It's like that's probably going to be the issue. It's like there's little. These things are semi-conscious, kind of doing their own thing.
It's that for AIs, the structure of the neural network is represented in the software, but the physical basis is still transistors lined up on microchips.
Yeah, it's still transistors. Thank you, lady.
In the human brain, in contrast, the network is a physical thing. It's one with the algorithm that runs on it. This difference.
Right. And it's not just the algorithm that runs on it like it's a computer. It's not. We're like a living tree being. People around us aren't actually separate cells. They're actually are part of us physically. We are just walking around, but these other pieces are actually us. So we're not just one little thing. It's all this combination of all of us together. We're not just inside the brain, ding dongs. That's where, man.
Is what scientists and engineers want to remove with the neuromorphic computers. These are built to resemble a human brain in terms of hardware, not just in terms of the algorithm that runs on it. This doesn't mean that they're built from biological.
That means they're just changing. Instead of having the neural network running software, it's just like adding up numbers, changing coefficients. They just put it in the hardware now. So it just runs a little faster. Okay. What?
Tissue, it just means that the connectivity
That's just the model, right? It's just the model. This is not actually how the brain works. This is their current understanding abstracted to a digital system.
and functionality of the biological tissue is reflected in the structure of the neuromorphic processor. So the thing doesn't actually look like a brain, it's still a box with wires in it, but it works differently than your phone. The term neuromorphic is somewhat vague and encompasses a lot of different things.
Okay, this is why I like her channel, because she does have some intellectual honesty here. They're just making these words up to get funding. Come on, stop.
In some research settings, for example, they basically throw a bunch of wires atop each other to create a network and call that neuromorphic.
Okay, so this is technically is a neural network because you have all these connections, and each one of these junctions has a different value that could be, if you shake this up 1,000 times, eventually it's gonna process correctly because how neural networks work. Come on, stop.
Some researchers have succeeded with teaching these wires to recognize hand-drawn
It's not teaching. It's shaking them up until they get the right result because they get the coefficients just right for that particular throw. What the hell?
numbers by adjusting how well the junctions
There's a lot of scamming going on in this intellectual. We're gonna make it like think like a person. No way. There's no way. And I'll get into that.
conduct electricity, and from there it's just a small step until they run for president. Somewhat more sophisticated than a hand.
That's the Eliza effect. People take this stuff seriously, think it's real. When it's just a blinking light on a keyboard, that's all it is. It's not. That's all it is. There's actually no intelligence in there. Now, someone is running that blinking light, making you think it means something.
Full of wires is IBM's True North processor that they first put forward in 2014. It had 1 million cores, each designed to resemble the way neurons fire in the brain, and specifically designed to map the virtual neurons of a neural net onto the physical ones. IBM has since updated
here.
and improved it.
This stuff is all cheating. This stuff right here. This is all. They're not. This is cheating. This image recognition stuff. It's been around since the 80s, maybe even the 70s. I was working with image processing technology software out of a book that was written in the 70s.
Its neuromorphic processors, but they're still far smaller than the human brain. The new computer to be built in Sydney is named Deep South, not just to acknowledge its location, but it's also a nod to Google's DeepMind.
It's all this ego stroking. Who's got the bigger dick? Stop. This is all just funding. This is all like hype funding, hype funding.
In IBM's True North. The new computer will, however, work completely differently than either. The researchers in Sydney want to use what's called field programmable gate arrays that are
It's still transistors, lady, and you know this. A field programmable gate array is just a way to program a bunch of transistors. It's just so basically think of a row of transistors, like they're all set up, and you can wire them in some. If you could wire them in some way, if you're allowed to, like in software somehow wire these things all up, well, you can make it do all kinds of crazy shit, and that's called a field programmable gate array. It's still transistors, lady.
basically small circuits whose function, in contrast to normal microprocessors, can still be electronically changed. These programmable arrays will take on the function of neurons and simulate, in particular, the spiking. That's the
simulate it? What about all the other stuff that's going on?
rather sudden threshold at which
What about all the stuff outside it?
neurons pass on information. In addition, they'll be building in some randomness into the behavior of these artificial
Oh, good. Randomness. Thanks.
neurons, because that seems to be playing an important, if not well understood role in the human brain.
Yeah, it's called the quantum field effect. It's like we live inside it. It's us. We're built in this stuff. You think that's not important?
The point of this research project is not to build a super powerful computer. That'd be more difficult because then you'd have to figure out how to train this neural network. For the moment, they just want to find out how the human brain manages to run on so little power. It barely needs 20 watts to operate, whereas training the currently existing artificial intelligences consumes huge amounts of energy. And
Yeah, because the technology is based on transistors, which is this whole other thing. Like, it's like not even compatible with biology. What are you talking about, lady? This is goofy shit.
running them isn't cheap either. Sooner or later, this will become a problem. Mapping the neural networks from the software to the hardware could dramatically decrease the energy requirement. Another reason that they use these
What?
field programmable gate arrays is that they're slow. You see, neurons in the human brain need a few milliseconds or so to update their state because it's all chemical reactions. You might find that fast.
Not all chemical. See, the thing is, here's it. This like reductionist shit. These science autists like to reduce everything to like, oh, it's just this, just that. It's just no, it's not. Stop. It's chemicals. It's electrical. It's the environment. It's feedback. It's quantum shit that we don't fucking understand. What are you talking about, lady? You live in a bubble. Sorry.
But remember that modern computer processors update billions of times a second, so they're easily 1,000,000 times faster than the neurons in our brains. If you want to build something that physically resembles a human brain, therefore, you need...
Yeah, because it's super simplified digital stuff, signals. It's not anything like the brain. Quit comparing digital electronics to the brain. It's not anywhere close. It will never be close.
low electronic.
Look, we got this thing that happened with these autists. They got some shit right, right? They got some shit right. Calculus, Leonardo da Vinci, blah, blah, blah. This Cartesian coordinate system, super useful. Yeah, super useful, no doubt. But it's not reality. This is not actually how things are in this universe. This is a model. It's useful in certain circumstances. And even then, it has its limits. Holy fuck nuts. That's not all it is. That's not all the universe is the Cartesian coordinate system. And then from this guy, he's like, since he got such a success, they were like, oh, he probably has all good ideas. And then he went over this Cartesian coordinate, Cartesian system where he splits the mind and the body. Like the mind is up here and the body's down here. That's a lie. That is a lie. The body and the mind have no separation. The mind is the body is the mind. There's more neurons in your body than there are in your brain. Your brain is your body is your brain. That's why when you exercise, it's like doing therapy because you pump all that shit up out of your fucking brain. Ding dongs. God damn, that's why you can't take, that's why these vaccines and shit are never going to completely do it because, or ever do it at all because we're not meant to operate like that. We're supposed to be moving around, pumping our lymph nodes and stuff. That's our brains. This is that head fake shit. And this is why I'm going to dog on these autists for thinking that they already have it all figured out and haven't taken a healthy dose of mushrooms or psychedelics or something that makes them like pop out like, hey, wait a second. There's another thing you haven't looked at yet that maybe you should see. There's this other thing going on that you're never going to explain. So quit it.
So this is what they'll be doing.
Quit thinking you got it all figured out. Quit thinking your degree means anything anymore. Come on, guys. You have to be, okay, get on the ball.
Complete the Deep South computer by April this year. It'll be remotely accessible for research purposes, though I suppose the waiting list will be quite long. Of course, this opens the possibility that once they've managed to get this done, they might be able to build a device that works like a human brain but 1,000,000 times faster.
No, it won't. Another thing, this Eliza effect. It's easily co-opted by evil forces who want to just fucking kill everybody. All right, I'm done with this. I'm going to leave links for all this stuff in the show notes. I've had about enough.
But the good thing about the American dream is that you can just go to sleep and try it all again the next night.